Welcome to the NX for Manufacturing Tech Tips. Today's tech tip is titled How to Make Any Hole with NX Cam. Demonstration will last approximately 20 minutes. We'll stay on the line and open up a chat window for questions and answers. With that, I'll turn the session over to Michael Hitchcock. Welcome, Michael.
Thank you, Derek. Appreciate that. Hello to everyone out there. I've got a few things prepared for you today. But Derek's was the end of the script, so everything I'm doing is just off the cuff here. So we'll go through and various things. I wanted to show a way to just approach hole making in general for just the run-of-the-mill holes, those that are fairly straightforward that we can get through. I want to show you the feature recognizer. I think you've spent a little bit of time with feature-based machining, but I'll do just a little bit of that relative to some items with holes particularly, and some of the features that come from that. And then I want to spend a little time with thread milling, both internal and external milled threads. With some new capabilities in the last few releases of NX that make that a much easier task than it has been previously. And then some hole milling also that we can work with, especially for larger holes where you can't drill them that big, or they're maybe a little bit more precise than you can drill, and you need to go in and machine those, mill those out. A couple of approaches for those that will be helpful. And then I found something really cool that I could do with manual hole making. You can define your own drill cycles. And there's a lot of times when you get in a situation where you're trying to cut some feature that's not an out-of-the-box solution, but you know what you want. Just a little bit of customization, you can do some pretty cool things. And so I'll spend a little time going through that as well. If I can get these arrows to work. So here's my example relative to that user-defined cycle. I got to throw up my best thing here and taunt you just a little bit, tease you, invite you to stay around in case you get bored with the other stuff. Oftentimes, and I've had this request a number of times, you want to come in and you want to drill this hole, and if you use just any of the out-of-the-box features that we've got, you'll get either a hole that just drills through the top one, or if you try to drill through all of them at once, then you get all this feed-rated move from after you break through this clevis here until you get down to this one. And if you do a second one, then it's pretty scary to be rapiding all the way from the top of this through this hole down to the bottom. You know what you'd like for it to do. You know what you'd really like for it to do is to drill the top one, not pull out of the hole, go at some user feed rate down to the next one, which would be higher than a typical drill feed rate, but you probably not want to go at full rapid. Then you want to move to some position down here. You want to drill through that with another cycle, and then you want to exit the whole thing at the same time back up to the original clearance plane. And I'll show you how you can do that pretty simply with a user-defined cycle from the manual hole making side.
Go ahead.
All right. So this is NX 8.5. And I'm just going to go in, just taking a part that's got a number of different hole type features on it, some counterboard, some that threaded holes, some large holes, just a variety of these. And we could come in and drill this with the old standard point-to-point. Frankly, that'd be a little bit of work. Selecting the holes wouldn't be too bad because most of them are just on a couple of faces. But going through the process of getting the right spot drill and then coming back and drilling them with the right one, picking all the tools, setting that process up to go through that, deciding what size holes they are. A lot of control, but a little bit of time to do that. So what we would recommend in something like this is to go do it in feature-based. Now I'm going to start from scratch on this because I think there's a couple of best practice items that would be well for everyone to see, and I try to influence everyone out there and show you this again and again. But this is just the part. This is the way it would come to you. This is not the manufacturing part. I really like using the template approach so that we make an assembly. So I'm going to start new, go to manufacturing. This is a metric part, so I'm going to do it in millimeters. And I'm going to use our Machinery Express setup. And it's going to create an assembly for me. And it's going to base it on this part and do that automatically because that's the way the template is set up to go. It brings my part in. And now I have, if I go to the assembly navigator, you see that this part's coming in here. I also have, now, here's one of the very first things I would do. Once I get this in here, I would make me a linked copy of this body. And I would make sure that I told it to copy threads, because this part does have threaded features on it. I added to it in an X. When it came, it was a dumb body. And for the feature-based recognition to be able to know that there's a threaded feature on there, we've got to have something that can. I'll tell it to hide the original and make it associative. That way, if there were any changes to the original model, they would flow through here. And essentially turns off the one from the component and leaves me with a linked body here. And that's the one I'm going to manufacture on. That way, as I'm machining or doing any things, I don't get linked planes in here from different places. I've got a whole body that I'm looking at. The other thing I'm going to do real quickly is I'm going to bring in some stock. There is a blank out here that I have made, and that would be what this would look like at this point before the holes went in. And so I want to bring that in, so if I want to do material removal, I can see what that looks like as I go along. So I'm just going to bring that in as its own component. As I go into manufacturing over here, first thing I'm going to do, of course, would be to set a coordinate system wherever I'd like to have one. Let's just go grab a couple of axes here and throw me a coordinate system here on this corner. And this is set up to be just a local MCS fixture offset 1, which will give us a G54 when we post. In my workpiece, I'm going to specify my blank. And then I'm going to go over here and turn that off so I don't have to see it anymore. I'll grab my part. So all my operations will know what I'm working with. So with that chosen, I'm ready to go recognize some features. We go in here to the Machining Feature Navigator. I'll right-click here and tell it to find the features. The dialog that comes up gives me lots of options. And I know you've had a look at feature-based machining in some previous tech tips, but I'll go through a couple things that are relevant specifically to holes. We have different types of recognition. Feature identification, you'd want to use that if you had an NX part so that you had the feature history there, that you could pick them up from there. We can identify those features as they were created. What I'm going to use today is parametric recognition. This is a recognition engine that will go through the geometry that's there and determine what type of items that we have, classify those. We do have the legacy hole recognition for a template-based approach to doing holes, and also the pockets from there, and then you can actually go do some manual recognition so if you want to. We're not going to work with that today. We're going to stick with the parametric. Wants to know what body I'm wanting to look at. Since I've already selected this in the workpiece, I can just select it and it knows what I want to, what piece of geometry I'm trying to pull features from. You see a whole list of different types of features we could recognize. I'm not going to have it recognize the bosses. I'm going to cut those myself. I don't want it to look at different notches and corners and things that are through here, so I'm not going to do any of those as well as any of the grooves. I am going to ask it to take a look at holes. I could have pockets on if I had irregular shapes I was wanting it to find. I'm not looking for those. Side notches, cutouts in the sides right over here might be a side notch. I'm not looking for those slots. But steps, I'm going to look at all of those. I want everything to try to look at any of those different step geometries that I've got down through here, because a number of these features have steps in them of different varieties, and so I want to recognize all of those. I'm not going to do surfacing. I'm not going to do EDM. I'm not going to use the colors today. So with that being done, if I just tell it don't worry about what orientation it is, just look for everything. If I ask it to recognize those features, it'll go through, and you see up here it's looking at the different ones that I ask it to look for. It tells me it finds a total of 38 and highlights those for me. You see that it's got these that are off axis. If this is a 3-axis machine, I really don't want those, and also the ones that are features from this side of the part. So I don't want all of those. So I'm going to say, don't give me that. I'm going to limit, specify a vector to say this is the direction I want you to look at. Only holes that can be machined from normal to that face. Tell it to look again. It goes through the process again. You see it running through. Now I've got 24 features. And still, some of these I don't want to machine and don't want it to figure out. I want to go do those myself. A couple of these step pockets here, single step 1 pockets. I'm going to use these to show you some of the hole milling capabilities. So I'm going to grab both of those, tell it not to put those in my group, and also this last one down here, 3-step pocket, because this thing's got a counter bore on both sides. I'm going to process that one separately. So I'll take those off and I'll accept the rest of them. So you see there the coordinate system at each one of them, all of them with the Z's pointing up. That's good. That's exactly what I told it to get. Now I can go through and grab individual groups of these and have it process those if I choose, or I can just say, you know what, go figure out all of those. So we will do that. Just say create the feature. Now we can change directions. We can take a specific hole and we can say, you know what, I want that. You've got that going the wrong way. I want you to look at all the data that it picks up on these. It knows where they're located in the part relative to coordinate systems. It knows the orientations. It knows angles. If we've got some chamfers on some of those or whatever they be. It also knows surface finishes, if there's anything attached to those, and we can make decisions based on those. You see the depths of all these different parts that are in here. If we get over, we'll way on over here somewhere some thread information for those features that are threaded. Knows what type of threads those are, so on and so forth. So it picks all that up from the model. And once we have all that information, again, we can edit some things in here if we want to, tag things, quite a number of things that we can do with that data. But right now I'm just going to tell it to process those. And this is coming from our default process library. We're using the rule-based approach, so it's looking at the rules, and these are the out-of-the-box rules, so I haven't changed anything there today. That's a whole other story if we want to get into editing those rules. I'm just going to make this under the workpiece geometry. I'm telling it to create new groups for each of these different types of things here, and I'm just worried about milling and drilling because I'm not doing any of the other things today. So I'd send it off to do that. It's going to give us a little status up here as it goes through and processes all the different holes, and you'll start to see information feedback over here in our operation status. This is actually a good thing to see the red not symbol. That means it created it. It's just not been generated yet. So it found everything that it needed. It found a tool. It was able to put together a process to manufacture all of these. We'll go back over, and we'll see that we've got them categorized by the type of geometry they are. We've got our step 1 holes. We've got some threaded holes here. We've got some, which I've got one on the screen. Smaller, some real estate. Another set of threaded holes. These are 2-step holes, so they're just a big countersunk, counterboard actually. And then some other ones, 2 steps into those, 2 steps on those, and finally those smaller holes over there. So those are the holes that I've got processes for. Go and generate all of these, see what they look like. But here's the process that it makes. So let's take these 2 holes here. These are about, I think these are about 1-inch diameter holes or 25-millimeter holes in that range, if I remember just from looking at those. It's going to spot drill them. I'll generate that one. It's just going to come in and do a spot drill. And then because of the depth, the diameter ratio of these, it's going to come back in and make just a little pre-drill down to a very small depth, and then it's going to gun drill them. And again, this is what the processes I have defined, and then it's going to come in with a next size larger drill and drill that, and then finally it's going to drill to size. So based on the requirements of this specific hole, to get this depth, this diameter, and with the tolerances and finishes that were associated with that, that's the process I have set up to do that. Now as we go down through, we'll see over here that these threaded ones, they're small, they have a different process. We spot them, we drill the inside, and come right back and tap it. So that's pretty straightforward. The next set of ones, because they're larger, has a slightly different process. We drill in the center, but then we actually drill up, and these have a significant chamfer on the top of these that we come back and specific chamfer operation for those, whereas because of the size of these, we were able to get these chamfers when we spotted them. And then the tap at the end. So the processes are different for the different features that are there based on the rules we have associated with them. As you go on down through, you see some are quite simple and some are a little bit more complex and have more steps in them depending on what needs to be done there. And the nice thing is I get all of that process without having to, because the rules are defined once, I don't have to go through and say, okay, got to go pick a spot drill and spot these, and now I need a bigger spot drill to spot these, and so on and so forth. With the range of things we've got here, we're just spotting them all with the same drill and then come back and boom, 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 process them according to some of them additional drill steps, some of them not. And that can all be changed in the rules. But this rule-based approach, or if we were to essentially do the same thing and use the template-based approach, give us very similar results, different ways to control the output that we get. With the template-based, it's essentially going into an NX manufacturing file that's been designated as a template and setting the way we want things to work in there and making AF that we have some of the rules to work right. But in the feature, or in the full feature-based machining, then we go into the knowledge-based rules, and that's where we would edit if we wanted to change the process in any of those. Okay, so that's the easiest way to do, your fairly standard type holes, even though they've got, and even some fairly non-standard holes, it works through that. Now, from here, let me grab the rest of these and generate these and do a quick material removal just so you kind of see what's there. Through. And we've got some smart things going in here. These things by default are set to recognize the part and know what's there. You'll see that when we're drilling holes in the areas of this boss as it's standing up, we recognize when we go across those bosses and we need to pick the tool up, and when we can just go straight across at lower levels to drill these features and all that. So there's some smart things going on in there. You go over the program group. These guys all wound up. Proper one there to associate them with, but that's easy to take out. And I can change the order, drag and drop these. You just got to be careful that you spot drill it before you gun drill it or whatever. If you want to change the order, that's fine. Get the tools in. But it's just NX operations once you've got them there. And they do recognize that there's some order involved when they come out of the knowledge base. If you start trying to drag, for example, we've got a set down here. If I wanted to pull this counter bore up before this spot drill, it would complain about that. Say, that's not a very smart thing to do. Are you sure you want to do that? And if you're sure you do, you can, but at least it gives you some feedback to say, we think we know what we're doing here, and it could cause a problem for you to counter bore it before you spot and drill it. So a little bit of smarts worked in there. So I'm going to grab that group and just tell it to go do a path verify on that. Kind of up here, and I'm going to have to slow this way down. I'll turn 2D dynamic on. I'll go as slow as it will, just so you can kind of get a sense of what it's going to do there. So now I've got it just going processing the holes in order. So you see the spots, the drills, the size up. Go down through the processes. You can tell which one is the gun drill, right? That big long button is coming in. If we drug across anything here, we'd see that as well. So we'll get some clearance analysis going through that. And so there we've processed all those holes. Still got a little work to do, but we've gotten that portion of it. So that's a nice, simple way to get a lot of that stuff done in short order and have the full process there. So the next thing I want to do is start looking at some of these larger holes and doing some threading. So I think I had the order reversed in there. I said I was going to talk about thread milling, then I was going to talk about some helical milling. Let's mill the parts down to size, and then we'll come in and thread them. That might be a little bit better approach. So I'm going to create some operations here. Actually, before I do that, when you go in to do the knowledge base stuff, it sets your template to be in the knowledge base. You don't have all the things there. If you want to get back everything else so that you can access everything else in manufacturing like you normally do, just come in here and reset your manufacturing preferences. Go to the configuration tab and reset these back to defaults. And then when you go over here to start your operations, you won't just be in hole making. You'll have all of the different milling operations and things available to you that you're used to seeing. It will be restrained down to just the one. So let's do a little hole milling here first. And I'm going to go grab something pretty good size. Let's get an end mill that's about, I don't know, let's get a 25 millimeter. And we'll workpiece, and we'll finish. And let's cut this boss here. So in here we determine what we're going to cut. Now we can do this on the fly, and when I do these holes here in a minute, I'll go and select those in a geometry group prior, and you can see essentially the same type control, just where you want to control it. So here we're going to do a boss, and as we select the object, you'll see it picks up the information. It knows the diameter of that feature. It knows the height of that feature. We can overwrite those if we want to. Right now, these are saying these are picked up from geometry. If we didn't want to, if we wanted to extend it or shorten it or whatever, we could do that, like changing a couple parameters there. We could also specify an orientation on the coordinate system, whatever we like to do. And as we pick more items, these would add to the list. So if I came over here and chose this item, you'd see that this is 71 in diameter and it's only 20 in height. But if I want to cut all the way to the floor, I can go here and say, well, what is defined, and make it 40. So now we'll cut the entire thing. It won't do the undercut yet. We'll do that in a minute. And so we're going to take a look at these menus here. Our cut pattern is helical. We're going to helix around this. This says, how much blank stock's here. If we say, there's 2 millimeters or whatever, and our axial and radial, we have axial and radial controls on how we want to approach this. So we have an axial depth per revolution. Right now it's set to distance. We can also say a ramp angle. So we can control this by saying, I want you to go at 3 degrees. And then we have a radial. Well, right now we're saying 50% of the tool. If we've only got 2 millimeters of blank, no problem at all. It's going to cut it all in one time. One other thing that we might want to be real sensitive to is our minimum clearance from the part. We might want to bump that up a little bit. On these, you don't necessarily start from center since we're on the outside. So there, that's a 3-degree ramp. Well, that's way too aggressive. So let's go back and say, let's change that to a distance. Instead of percentage of the tool, I want you to go 3 millimeters per revolution. So now we see, a lot different looking. Run into that. As you look at that, you'll see that we come into the tops, we helix into the top of it, and we work our way down continually in that helix. And that is a helix. If we look at that, our output, you'll see that it's defined as a circle record times, when you see times in some number, that's how many revolutions. And that's going to come out, and if you run that through our posting software, obviously through Post Builder built software, the helical engage is going to, or the helical operation is going to pick that up. Know that according to whatever you've got set in the post processor, to know how to output that, whether you can output an entire helix or just 360 degrees at a time, or whatever the requirements of your specific controller are, and process that. And then you've got circle records to finish up at the bottom, because if you look closely at this, you'll see that after we get all the way to the bottom, then we make a full revolution all the way around it to clear. So lots of controls over how we want to handle those, and work with that, whether we select them individually on the fly or we go and do groups, which is the next thing I'm going to do now. Is I'm going to go over and do a group, go to the geometry view, and say what I really want to do here is I want to make some whole boss geometry, and I want to put that underneath the workpiece. And grab a couple of holes. So when I grab that hole, puts a coordinate system there, so I'm at the center, you see the orientation, gives you a size. This is 75, 50, and 45 deep. Grab another hole, and it picks it up and puts it in the list. So the features can have different parameters because we're looking at all that all the way through. We don't really want those to be through. Those are both blind holes. And that simply in our geometry view. My mouse is double click for me every time. It needs to have an attitude adjustment. Okay, I'll try.
Hey, Michael, can you adjust your microphone
mic just
for
about
us?
has to be in my teeth for you to hear me, I think. Is that better, Derek? So it created a whole boss geometry group over here in the
it is, thank you.
in the geometry view, and now to when I go to do that, I will select the geometry as my whole boss geometry, and now it knows what I'm wanting to cut. So we'll call this hole milling, and we'll actually call these holes. Should have said boss on the other ones, but we'll know what it is. So now, how do I want to cut these? Again, same type of parameters. Now, if you noticed here, it's got options on what defines my blank. Well, if I say that I've got a 0 diameter, start diameter, it knows it has to cut in the middle. If I make that larger, it'll expand out. If I just say distance and say 0, it's going to say, oh, there's essentially no material here to start with. And if I generated that, I'd get one pass around the outside. That'd be a little hard on the cutter, so I'm going to go back and say starting diameter 0, and these are my actual 25% of the tool and stepping over 50%. But you see a different thing happen. Now you see it starting in the center and working out 50% of the tool at a time. Again, we've got the same type of controls on where we're going down, whether it's a distance or a ramp angle. If I change that to be 10% of the tool, you'll see a lot more spirals going down. They get to, it's just, controlling it if I want, again, I have hard numbers that I want in there as well. And the step over, I don't want it stepping over half of the tool each time. Let's go down a quarter of the tool each time, and you'll see more step overs going out. But really, this isn't the way I wanted to cut this hole. What I would really like is a helical spiral mix. So what I want to do is helix down in the middle and then spiral out to the edge of the part. And so now I get different information feedback choices here. So what I'm going to do is tell it, how big of a helix do I want? Well, this is a 70-ish millimeter hole. So let's cut about, and this is a 25 millimeter tool. So let's cut about 35 millimeters with that. And then let's see, our depth per revolution is at 3 millimeters. Our axial step over is half the tool. That may be a little bit more than we want on there, or it may be fine. Change the number, whatever we want. And then actually what I may want to do on this is change this to a distance. So instead of percentage of the tool, I want it to go down 70 millimeters of time or something. And then radially 25% of the tool. That sounds pretty good. So now what I get is a very different looking path. So now I helix into the middle till I get to a certain depth, and then you'll see that I spiral out and then clean up the outside of this. And I've got, based on the hole depth, I've got about 3 steps down on this. I think this is worthwhile to see it cut. I'm going to go and just do material removal on this real quick. Create the IPW there, and then I'll just let it go. Hopefully it'll go slow enough that you can get a sense of what it's going to do without me having to step it. But you see it helix down in the middle, and then you see it spiral out to the finished shape. And I think this is a pretty efficient way. And again, this is all arcs. You get a helix going down the middle that's a true helix. And each of those moved out, unless you, of course, I mean, there's always an option in here for you to go to machine control or in your posts linearize it. Actually, we don't we don't put that option in here because we figure if you're cutting it this way, you want arcs and not points. You can customize in a linear ability for some reason to. If you really want lots of data, because if you have 5 meg file going out, it looks like you're doing more work than if you just have one that's a couple meg or something. Then that might be a good way to do that, to output points. But we do output circle records for all this. It's just continually in larger radius circles as they go out and are tangent to one another, so you get a nice smooth flow out. But I think that this is a very nice way for cutting these larger features. Or if we had pre-drilled these and wanted to just cut the outside, we could go back to a helical and say that our starting diameter was, let's say that it's 50. Then we would just get cuts on the outside, again, based on the parameters that are there. So a lot of flexibility in this, but in a very nice interface to be able to work with on those larger holes. We could, again, do a similar type thing over here with this stepped hole. Let's use just a little. This is a bigger hole. Let's use just a little bit bigger tool. And we can select this one on the. Let's use that whole boss geometry, and it's trying to. So let me go back in and select this. Going to do holes. We can select that object. You notice that it says that's 139 diameter, 10 deep. Go to the next one. This is 125, 80 deep, and so this will stop cutting down at the bottom before it gets to this last feature, if that's the way we have it selected. So again, if we want, we can unlock that. Say we want that to be user-defined, and so instead of that depth, we can put in 90. And it will cut all the way to the bottom. So, there's a helix. See 2 separate ones. It knows to cut the top one and then cuts the next one underneath it. And we have blank distance of none. If we go to diameters, then you see it cutting all the way down through. Very flexible way. Again, we have those same options. We can go back to helical, spiral, or whatever different ways to cut that. But approaching those, we got a number of different ways to get to that, and a real nice way to finish those. Now let's cut some thread. Oh, we got an undercut over here that we need to do. Let's go do that one real quick as well. Using this same hole milling approach. And obviously I should have changed my tool before I went in here, but I can change it anywhere that I want to. I've got a T-slot cutter down here. And if we want to display that, that's just what it looks like. So on this, again, we get to go select some geometry. And this is going to be a boss. Grab it. It's fine. A couple parameters here. Let's see, we're going to spiral on this one. And we'll say this thing's starting out at 68 because that's what we cut it to when we cut the top part of it. Our axial step overs, change to a different option here. Let's do a couple passes at 5 millimeters. And then radial step over, again, let's go to some, let's try a couple millimeters. So what we'll see is the first pass up here, spiraling in, cutting right next to the top. And the bottom pass, of course, cutting on the floor. Another one, again, just a little heads up on this. Always check what your minimum clearance is to make sure that you're far enough away from the part. Gauge on that. That one's pretty close at 3 millimeters. If we wanted that to be a larger number, again, we just go in there and say double that or something. Generate it and start out. You can see we're quite a bit further off the part now. Clearance away to it. from it, from the part itself, as we start that motion going. This will just be a pure spiral in and then finish up with one full arc around the inside. So it just walks around and around the part, getting closer and closer with a constant 2 millimeter. I think I had it stepping over, and then it's going to reposition and come back and cut the bottom one on there. It recognizes the part, knows to stay off of it and not hit what's declared as part geometry. So we're undercuts, whatever type thing. This processor works well, fine with that. We have the 3 different options of spiral cutting, helical cutting, or a combination of spiral and helical cutting, where it makes sense. Now let's go do a little bit of thread milling.